All right, solving rational equations, 9.3, day 1. We're going to solve rational equations two ways. We're going to do it by graphing, and I'm going to kind of go through it quickly because graphing can be a very difficult way of solving it. Then we're going to do it algebraically, which is a more simplistic, straightforward method. So to graph it and find the solution means we're going to actually figure out where our graph crosses the x-axis. We're looking for the x-intercepts. So we have to set our equation equal to 0, and we pick table of values. We're going to pick values on either side of 3, not 3, because 3 blows up our denominator, which means it's undefined at 3. We have an asymptote at -2, 1 at +3. So I'm going to pick the values 0, 1, 2. If you notice, I already plugged them in and got the answers. You can go ahead and plug in the values and check it yourself. But when we plug in, we get these values. Notice, I didn't actually pick necessarily all in a row. I picked values that were easy to deal with, meaning I knew I was going to take the top number and divide it by whatever's in the bottom. So I tried to pick numbers that would give me 1 in the denominator or maybe 2, making life a little easier. When we graph this, this comes along, and it's going to do something like this. This branch doesn't cross our axis, but when we look here and we start graphing this at our points, it's going to actually cross at 6. So if I plug in 6 here, 6, and this down here gets 3. 6 divided by 3 is 2. 2 minus 2 is 0. So that's my x-axis, and that is my also where it crosses the x-axis. That's my x-intercept. So my answer is really just 6. I don't really particularly care for graphing and finding a solution, although it is valid. It works great with a graphing calculator, but not so much if you have to do it by hand. Here, solving algebraically is pretty easy. I'm going to multiply both sides by my common denominator. We've talked a lot about common denominators. So I'm going to multiply this side by x minus 3 and this side by the x minus 3. Well, when I do that, the x minus 3's cancel. I get x equals, and over here, 2x minus 6. So if I subtract the 2x both sides, I get negative x equals negative 6. That means x is positive 6. There's my answer. This is the same problem that we did graphically. To me, much easier algebraically. Looking at another one, we need to factor this denominator because we need to be able to state restrictions and we need to be able to multiply by the common denominator. So here, looking at this, our restriction is x cannot equal 5, just like we stated over there, x cannot equal 3. We stated at the beginning, blows up the denominator. So we're going to multiply both sides by that common denominator. We're going to multiply both sides. Let me grab the blue marker. I'm going to multiply both sides by 2 times x minus 5. And this side, 2 times x minus 5. Now, this denominator cancels with this one. Here, this side cancels with this. As long as I'm doing the same thing to both sides, I'm not changing my equation. But in the process, what I end up with is a 2 times 3x plus 7 equals 5x plus 17. Distribute that 2, and we get 6x plus 14 equals 5x plus 17. Subtract your 5x both sides. So we have x plus 14 equals 17. Subtract that 14. And x equals 3. And you do need to double check to make sure that x is actually not your restricted value. Since I can only not have it be 5, it's 3. We're good. One more example. Here, we get to figure out the common denominator. So in this case, we need one of every value, x minus 7 and a 2, and we're going to multiply each term by that. So 2 times x minus 7. This one, 2 times x minus 7. Here, 2 times x minus 7. Now, for some of you, I'm going to do this one a little bit longer and show you the long way out, because some of you need to kind of write this down. I have a 2 times x minus 7, 2x minus 9 on the numerator. This is a 1 on the denominator. Denominator has an x minus 7. Plus, here, numerator, we have an x times 2 times x minus 7. Denominator is still a 2. Equals 5 times 2 times x minus 7. On the denominator, if I multiply x minus 7 times 1, I get x minus 7. So in this one, I've written it out the long way. And now I'm going to go through and cancel common factors. x minus 7, x minus 7. Here, this is 2. I can cancel with this 2 because they're being multiplied. And then on this one, x minus 7, x minus 7. Notice, everything canceled in the denominator leaves me with a 1. So I have 2 times 2x minus 9 plus x times x minus 7 and a 5 times 2. Now I'm going to go through, I'm going to clean this up and distribute my 2. That's 4x minus 18. It only gets distributed to what's in the parenthesis. Here, x times x is x squared minus 7x equals 10. We need to condense this down. I get x squared minus 3x minus 18 equals 10. All I've done is collected the like terms. And we need to move it over so it's equal to 0. So x squared minus 3x minus 28 equals 0. Factor it. That means x is 7 or x is negative 4. You set each factor member to 0 and solve them. We check. Is 7 or negative 4 one of our answers? It can't be. So we need to go back and look. Restricted values. We have a restriction here. We have excluded values. X cannot equal 7. When x is 7, it blows up our denominator. Now, that means that this is called an extraneous solution. It's an answer that we got, but it doesn't work in our problem, even though we've got it as an answer. So this gets tossed out, and our only answer is negative 4. Sometimes both answers will be tossed out. That means you have no solution. But that happens very rarely. Get your notes Cornell note style, and I will see you tomorrow.